Hi, my name is Catalina Serra, and this is my final project. Just to recap and summarize a little bit, the objective of my project is to measure the height and estimate biomass and volume of the trees that are located at the U.S. Marine Corps War Memorial. This is in Arlington, Virginia. The location has several standing old trees and is also very close to my house. And I thought I was going to be able to conduct a ground check so that I could perform an accuracy assessment. I choose this area because it's not that big and because I managed to find LiDAR data of good quality. So this is the project boundary. I created this polygon in ArcGIS. As you can see, it is very close to the Potomac River, which is in between Washington, D.C. and Arlington, Virginia. And it is, of course, in the United States of America. So the data sources, I took my LSA or my LiDAR points from the U.S. Geological Service. I searched by area of interest and I got some good files from the Sandy Restoration program that took place over Virginia, Maryland, and DC. The data was collected by the company Quantum Spatial using the sensor called Leica ALS-70 with a nominal field spacing of 0.7 meters. And the coordinates were the UTM zone 18 north and at 83 meters, and the vertical datum was NAV 1988. The type of LAS files was 1.2, and the data was collected in winter. But there was no snow, so it was able for me to even check the trees. Also, these trees are non-deciduous, I mean they are mostly evergreen, meaning that they don't lose their leaves during winter. So I was able to use this data because of this. The individual tile measures 1,500 meters on each side. Well, these are the data sources. I explained this on my previous videos. I was able to download the data and the metadata from the same website. In terms of the software, I was supposed to use LP360 and ArcGIS Pro, and well, I think I managed to use both. In terms of the workflow, this was updated compared to the previous video that I showed. Here, what I did was to first explore the data and the classification that came with it, and then I applied a few filters that gave as a result a good standing tree that I was able to measure first in LP360, and then I measured it in ArcGIS by creating an NDSIM, which is the subtraction from a DM and a DSM. And then I was able to get the final tree height, and I performed an accuracy check, but based purely on observation. And then I got the final product that I'm going to show you in a moment. Okay, so the first thing that I did was to clip the area of interest to the two data sets that I downloaded from the USGS website. So as you can see here, I only have the points for my area of interest. I included a buffer just to make sure my data was not damaged or cropped incorrectly. Here you can see the data display using a classification mode with points. Then in live view, you can see the trees, the two standing trees that you can see right in the middle of the screen were like my area of interest. Further to the right side, there's a river, but in reality, it's quite far from from where my trees are. And then on the 3D display, you can see the ground points and the trees. When exploring the data, I saw that the data was already classified, as you can see here on this slide. It had classified points, ground points, water points, unuse points, bridge deck and high noise, and finally reserve points. This data was created to have high quality bare earth products. And so when checking the ground data, I was able to see that it was a good representation of the ground data. There are some minor like inconsistencies there, but it's like on the left on the screen you can see on a almost blue circle there is like a hole, and this is because there's a bridge there, but that's falling outside my area of interest. Therefore, I didn't do anything with those bridges. Then on the left, you will see on the 3D screen the ground, which is it's pretty much what I was expecting. There is this square on the bottom left side of the 3D screen, and this is the Netherlands carillon. This is this monument that is there. Then when checking at the unclassified points, I was able to see that most of them were falling on the trees. So I performed some filters using live view, and I changed the size of the points. And this is where I can see here in gray that most of these unclassified points were falling on vegetation. And then also bridge deck points were also appearing on trees, but I wasn't able to reclassify them because the description of the classification from the product itself didn't say much about these bridge deck points. Therefore, I left them untouched. Here you can see all points display on a theme. And then assuming that the memorial has more than 25 years old or founding, it is possible to say that these trees are already mature or older than 25 years. And because of the species, I would say that they can have a height that goes between 25 meters and 100 meters. The species that are in this part of the memorial are mostly white oaks, red maples, and willow oaks. These trees can have a height ranging between 40 to 100 feet, and they can live between 300 and 500 years, especially the oaks. And so at this point, I will assume that these trees are already mature, but maybe they have not reached the major height point. However, the carillon, the tower that you can see here on the right, has about 120 feet in height. This is about 36 meters. And there are no trees higher than the tower. In fact, most of them seem to be approximately 50% lower than the tower. This is about 60 feet or 18 meters on average for the trees. Also, there are smaller trees, but on average, I would say most trees are 18 meters. This is a preliminary estimate without looking directly at the points. But with this, I was able to assume that anything bigger than 60 feet could be considered as high noise. Then what I did was to apply a PTC that it's called a high filter. And well, here you can see the filter. I classify vegetation depending on different thresholds, from 8 feet, from 1 feet to 8, then from 8 to 30 feet, that was medium vegetation, and then from 30 to 60, that was high vegetation, and everything beyond 60 was considered high noise. And you can see here on the right the table with the classified points. You can see there are already points in the vegetation categories, and the high noise points were also increased. However, the results are mixing or seem to be mixing two types of vegetation in one single tree. Therefore, I decided to adjust the filter to remove medium vegetation and make that one single tree could fall into one only category. But I got the same results. It seems like in some cases the crowns of the trees seem to be mixed or combined, and in other cases the crown of the tree is displaying two different points. As you can see, we have like two colors. In any case, with this classification, I was able to isolate the trees. As you can see, there is an arrow at the top of the screenshot, and these are my trees. And on the bottom, I was able to measure those trees, and I got approximately 19.5 meters in height, just measuring this. Then what I did was to create a digital elevation model and a DSM. So of course, to create the DEA, I use the export tool. I choose the class points. I source only ground points that were in class 2. The surface method was a feet, and the cell edge length was 10 map units in feet. The surface attribute was elevation, and well, as you can see here on the left, this is the exported DEM for my project. And then I create a DSM following the same instructions, only that I choose this time all points and only the first returns. And this is what you can see here. After this, I took these two files into ArcGIS Pro. First, I set the coordinates in my map, and then I uploaded both rasters, and then I conducted the I executed the raster calculator to get my NDSM and be able to see the height. So as you can see here, this is the final product. This is the result. There are some thresholds. I decided to show them in these colors. There is a negative, but it's very significant. There's maybe because of the slope, which I wasn't able to consider. This is all like a hilly mountain, so it might impact the results, but I wasn't able to correct that. I still don't know how to do it. So as you can see in this almost blue square, these are my trees, and they fall into the 4 category, which goes from 14 to 25 meters. And this makes total sense when compared with the 19 meters that I go using LP360. So all in all, I can say that my trees are or have are located in a range that goes between 14 and 25 meters, and we're looking at them in an isolated way, they can reach 19.5 meters. And this is one of the products that I was expecting to obtain. So what are the deviations from the project idea? First, I didn't have time to conduct the field check. I mean, I did go to the park. I go every day, but I wasn't able to use a clinometer to measure the height of the trees. and so I did a visual inspection of the height, and I got about 20 meters. But of course, the crops, no, sorry, the crowns of the trees are mixed, so it's hard to really tell without a clinometer. So this is something that I didn't do and that I was supposed to do. Then I only measured a few trees and all the trees in the entire area. Because I still don't know how to measure large masses of trees. So I thought it was easier to only measure a few trees. And I wasn't able to estimate volume or biomass. I will need more time, but it's only a matter of finding an allometric equation and using the estimated height that I got. And then finally, I think it's very important to ensure that the quality of the product it's very high, especially in terms of nominal space points, because I read that for trees, it's important to have at least 8 points or between 5 and 8 points per square meter, and I had less than one. So maybe that's one of the reasons why I wasn't able to measure trees when they are accumulated in one specific area. And then I found that LP360 is quite useful for analyzing LiDAR, but I wonder if there is any other free software that I can use after the end of the course. All in all, I think this was a very nice experience, and I was able to achieve my main objective, and I'm very happy for that. Thank you.